All right, good evening, everybody. Welcome to our meeting to present out on the draft findings from the Incident Investigation Root Cause Analysis Report for the Martinez Oversight Committee meeting. Before we begin, I'm going to hand it over to Supervisor Federal Glover, but I do want to let everyone online know that we do have Spanish translation available if needed. Jennifer, if you could please let the crowd know how to access that. Thank you. So we'll go ahead and get started, and I'll turn it over to Supervisor Glover.
Okay. Well, welcome. I want to welcome those in the audience that are there and those who are on Zoom. And really just thank you for your patience throughout this process. You know, our goal has always been to prevent incidents like this from ever happening again. The report you'll hear tonight examines why the incident at MRC happened in November of 2022. The report also offers recommendations to MRC to modify their policies and practices so another incident of this type never happens in the future. At the end of the consultant's presentation, there will be an opportunity for members of the public to comment on the report, which will become part of the official records. And our hazmat staff will explain how you are able to do that later on. I will now turn this over to Nicole Heath, Director of our Hazardous Material Program.
Thank you very much, Supervisor Glover. Good evening, everybody here in the room with us and everybody on Zoom. We are going to have a presentation today of the draft findings from the Incident Investigation Root Cause Analysis Report prepared by Scott Berger and Associates. Before I introduce our speakers, I do just want to give everyone a quick run of show. We have scheduled this meeting from 6 to 8 p.m. and I am allotting about 1 hour's worth of time for public comments. When it is time for public comment, we will start with our online audience first, and then we will move to the speakers in the room. Everyone will have 2 minutes for their public comments. Part of this public comment process is that we will take all of the comments from the audience, from those who are online, and comments we received during this 45-day public comment period, and incorporate those into our final report with responses from both Scott Berger and the county as necessary. So now I'd like to introduce our consultants, Scott Berger and Tim Maloney. Scott and Tim were chosen by the Martinez Refining Company Oversight Committee to perform an incident investigation root cause analysis of the November 24th, 2022 spent catalyst release. So Scott, I'll turn it to you to begin the presentation.
Okay, thank you, Nicole. Let me share the screen. And hopefully at this point you can see the presentation.
Yes, we can see this, Scott. Thank you.
Oh, excellent. Thank you very much. Okay, so let's get going. So first of all, let me introduce myself and Tim, so you can you know who we are. So we're both from the profession of process safety. I got a bachelor's and master's degree in chemical engineering, and 45 years of experience, of which a lot of which was in the area of process safety. I spent 14 years before my retirement as the executive director for the Center for Chemical Process Safety, or CCPS, and I've been an independent consultant since that time. I'm certified by CCPS as a process safety professional and been recognized as a fellow of CCPS and of AICHE. Tim, would you like to introduce yourself? If not, I can just keep going. And I'm not sure if you can unmute.
Thanks, Scott.
Okay,
yeah, so I've been in oil and gas, energy industry since 1983. Spent 25 years with a refining major. The last 12 years of that was in positions of leadership in process safety. retired and started a consulting business for process safety in 2017 and have been involved in that since that time. Also have got about 15 years experience doing incident investigations. And my experience also includes 12 years operating an FCC unit, a catalytic cracking unit, similar to this one. So thank you, Scott.
All right, thanks, Tim. Okay, so we have been brought in to address the incident that we see here on the screen. It was a release of spent catalyst dust on November 24th, 2022. It went into the morning of November 25th from the catalytic cracking unit of the PBF Martinez refinery. There was physical evidence of the release that was observed in the community and reported by community members as white powder deposited on various surfaces. And I believe this was throughout the town of the city of Martinez and also somewhat in Venetia. The Contra Costa Health contracted with our team to perform an independent root cause analysis of the release. And we'll talk about more specifically what a root cause analysis is in just a bit. But when we completed our work, we just to summarize our findings that we'll get into in a lot more detail, we identified 8 management system deficiencies, which are the definition of our root cause. And again, we'll talk about that some more too, that dealt with how MRC assessed the risk of catalyst release of that scenario, how they prepared and they followed procedures in the way that they trained the personnel that were operating that unit, the way that they empowered employees to stop or pause work in unsafe situations or when things aren't going as expected, and in the way that they managed worker fatigue. And we'll talk about that in a lot more detail. We're going to go through our objectives and approach for this work. We'll give you an overview of catalytic cracking. We'll talk about how the incident evolved, sort of the timeline of things. We'll get into our root causes and recommendations at the end. So our objectives was to identify root causes, and specifically what we mean by root causes are gaps in process safety management systems. So we don't look for, the root cause would not be an equipment failure, it would not be an operator error. It's how the way that the policies, the practices, the way that the leadership of the refinery enforces their policies, that's what we're looking for, is where that might have broken down. We also look at contributing causes, things that helped the incident occur. They weren't necessarily root causes, but they did factor in. We'll make recommendations to prevent future incidents, not just this particular incident, but any incident that might be enabled by those management system deficiencies. So it's a sort of a multiplier effect there. What we did, we were on the site to interview key MRC personnel. We reviewed a lot of their documents as well as data from the control system. We then followed the investigation approach that was published by the Center for Chemical Process Safety, which is a pretty standard approach for investigating incidents, finding root causes, and making recommendations. So let's start now with a quick overview of catalytic cracking, because we do start talking about a lot of terms, and it'll be helpful, I think, to understand how it's supposed to work. And the MRC catalytic cracking unit is a little bit different than other refineries. But anyway, we'll describe that. And it starts kind of in the center of this slide with the reactor. And the purpose of this reactor is to react or crack larger hydrocarbon molecules into smaller ones. And essentially the purpose is to make material that is more suitable for use in gasoline. To the right of the reactor, we have a a vessel called the stripper, and we'll talk about its function. There's also a regenerator, which is used to clean up the catalyst before it's reused. And then over on the left-hand side, we have what's called the main fractionator. And this is one of numerous distillation columns that are taking product from the reactor and turning into various useful components. Now, the process starts by with the feed of uncracked hydrocarbon into the reactor, and it's fed concurrently with catalyst that's been regenerated coming from the regenerator, and the two flow upward through the reactor where the cracking reaction occurs. Now, the cracked gas will pass overhead from the reactor into the main fractionator, where some separation will take place. The lighter components, the lower boiling components, will go up from the top of the main fractionator into a vessel called the overhead accumulator, and from there will be pumped using a device called the wet gas compressor to other parts of the process for additional processing. Now, that wet gas compressor also serves a second purpose, which is to control the pressure at the top of the reactor. And so this will turn out to be somewhat important as we go through the discussion. Now, the catalyst that comes from the reactor has some hydrocarbon entrained with it. And so the stripper tank is used to remove that hydrocarbon from the catalyst, and it passes out of the stripper and joins the flow of cracked gas into the main fractionator. Now, from the stripper, we have the catalyst basically flowing both due to pressure between the reactor and the regenerator and a little bit of gravity, and its flow is controlled by the stripper slide valve. And again, remember that that unit, because that will prove to be important as we go through the discussion. Now, in the regenerator, the purpose there is to burn coke from the catalyst to reactivate that catalyst. And that's done by contacting it with hot air. And that's blown into the regenerator, into the bottom, and that passes upward through the catalyst, burning off that coke. Now, as the air leaves the bed of catalyst in the regenerator, it's carrying with it some catalyst fines. And there are two of these cyclone separators at the top of the regenerator, and their purpose is to remove the bulk of those fines and return it back to the catalyst bed in the regenerator. So that's what their function is. Now, from there, the air containing still a little bit of catalyst fines passes on through a third stage separator and a fourth stage separator. It's going through a pressure controller, which is controlling the pressure of the regenerator. So now we saw that there's a pressure controller for the reactor and a pressure controller for the regenerator. Now, the air that goes through these additional separators still has a little bit of catalyst fines in it. That air passes on to the CO boilers, and from there to the electrostatic precipitator, which removes the most of the remainder of that catalyst to give a clear opacity from the stack. Now, this fourth stage separator, unlike the other separators, the catalyst has to be drained manually on a periodic basis, and that's usually done once or twice per shift. And as you'll see, this was happening. There was a difference during this incident that we'll talk about. Also want to mention that from the overhead separator, there is another line to a flare system that is used by the CCU, the catalytic cracking unit, under different kinds of emergency conditions. It's also used by other columns that are in the that are downstream of the main fractionator. But it is there, and of course the flare was used that day. So let's talk a little bit of a timeline here. Now there's a lot of things that happened, and some of these I'm going to skip over. But essentially everything began on the 21st, very early in the morning, when a component on the regenerator air blower failed. And so when that failed, the air blower no longer could bring hot air into the regenerator, and that basically triggered a shutdown of the CCU. So what happens during the shutdown is two things. One is the feed to the CCU is diverted over to the main fractionator, so there's no more feed going into the reactor. And the second thing that happens is that the electrostatic precipitator is shut down. And that is a safety measure that's been implemented in the industry for about 9 years, ever since there was an incident involving a shutdown catalytic cracker unit where vapors got into the electrostatic precipitator. That's done at refineries around the world. Now, when this event occurred, a key employee of the refinery with a lot of expertise began a schedule of working excessive hours, and essentially working more than 20 hours per day over 4 days. So this is where the fatigue comes in. Now there's a series of repairs to get the unit ready to run again, and the restart began early in the morning of November 24th. Not simultaneously, but in that morning, before the startup began, there was also a release from the flare to the flare from the compressed gas plant, for basically the columns that are downstream of the main fractionator. About 4 o'clock in the morning, the CCU was ready for startup. Actually, it was a little earlier than that, but at 4 o'clock in the morning, as the personnel stepped through the procedure of restarting, they put the stripper slide valve that we had talked about into automatic mode, which is what the procedure called for. And normally during the startup and during normal operation, it's supposed to be in automatic mode. At 6:29 in the morning, there was an upset in the CCU that required an operator to take manual control to correct the problem. And so that was done. And that problem, it took about an hour, but it was corrected around 7:30 in the morning. However, the stripper slide valve was left in manual mode, where it remained. Also want to mention that there was a second flaring event as the feed was initially introduced to the reactor, as well as we had been I guess during the startup procedure, it was necessary to bring some propane into the wet gas compressor in order to help it operate during the startup. Because normally there isn't, during the initial parts of the startup, there's not enough gas for the propane to run on its own. But that had been going on because of all the delays for several days. And so the inventory of propane had run down pretty low. And there was a communication from refinery logistics that the CCU had to be careful about their use of additional propane. And so this key employee A, at this point now, 4 days into those long shifts, instructed his colleagues that there should be no flaring, and they can continue to use propane, but don't take any more. So that was an additional factor. Okay, so now you can see where we were as the incident begins. So you can see on the slide I've marked an A and a B. And A is the main feed to the reactor, and B is the feed that's bypassing to the main fractionator. And so as the startup progressed, the flow through A was being increased, while the flow through B was being decreased slowly. And meanwhile, while that was happening, and there was more product than going through the main fractionator, the refinery was cutting back on the use of propane. But in any case, at about 8:30, there was an increment of feed to the reactor that was a little bit larger than expected, I believe, and that caused a pressure surge at the top of the reactor. And so because of that pressure surge, now there is more pressure also on the stripper. And so the pressure was pushing catalyst at a high rate into the regenerator. Now the stripper slide valve was still in manual at that time, and the personnel began to crank down to close it down, but did not close it down fast enough in manual. Of course, if it was in automatic, it would have closed down a lot quicker. So then what happened was the regenerator went to high level. There was too much catalyst flowing in, much more flowing in than was flowing back out through the regenerator slide valve. And so the regenerator went to high level. It choked those two cyclones, blew a lot of catalyst over into the third stage separator and into the fourth stage separator. The fourth stage separator went to high level, which means it was well above the design level and probably more than full. And catalyst began flowing at a rapid rate over to the CO boilers through the deactivated electrostatic precipitators and then out the stack. So that was the beginning of the incident. Now the personnel in the control room of MRC did not recognize that a release was occurring. They didn't associate a high level in the fourth stage separator with a potential release. Also, because the electrostatic precipitator had been de-energized, the opacity meter on the stack was already at its highest reading. And so when the catalyst rate increased out of the stack, there was no way to know that it was coming out faster. There was no catalyst observed falling inside the refinery, and there was really no communication from the community until after daylight on November 25th. So here's a little bit of a timeline talking about this period in a little bit more detail. The feed was started around 12:30 in the afternoon, and it continued on until 6:15 in the morning when the feed reached its full rate. And as we mentioned, the stripper slide valve had been in manual since 6:30 in the morning, and it didn't go into automatic until 11:30 p.m. at night. The fourth stage separator went to high level almost immediately. But after the stripper slide valve went into manual, it took a while for the material in the separation system to come out. The personnel were draining the fourth stage separator more or less continually through this period, trying to remove catalyst and allow that unit to start functioning again. And so what we can deduce from that, and also from footage taking from a neighbor's doorbell camera, is that the period of high catalyst release went from 8:30 to 11:30, and that's probably the bulk of the release. But that catalyst did continue to be released from 11:30 until about 4:30 in the morning, when the fourth stage separator finally had been drained and was able to resume its normal function. After that occurred, we were basically back in the situation that we were before feed was reintroduced, that high opacity condition that occurred when the unit shut down. And by 6:15 in the morning, when the catalyst, or I'm sorry, when the feed rate reached its design condition, it was possible to re-energize the electrostatic precipitator, and the refinery or the CCU emissions were restored to normal opacity. Oh, here we go. So let's talk about our simplified causal tree. Now, when we do a root cause analysis, we start with what was the event that led to the release, and then we start asking the question, why did this happen? And we come up with a number of hypotheses, some of which we will confirm, some of which we will refute. And for simplicity, we're trying to only, for the most part, talking about the things that we were able to confirm. So one was one of the causes for a high level in the regenerator, leading to the release of catalyst, was inadequate safeguards guarding against this kind of situation. Another was that there was a high catalyst flow from the stripper to the regenerator. So then we asked the question, well, why did those two conditions exist? And we found that that the process hazard analysis and risk analysis that was conducted basically used documentation that underestimated the severity of a potential catalyst release. Okay, so that was basically a gap in it basically failed to identify that this was a serious release. As far as the high catalyst flow, it was obviously because the stripper slide valve was in manual, and also because it wasn't moved fast enough by the operator, or aggressively enough. Now, we also considered that the possibility that the stripper slide valve was malfunctioning. However, we were able to rule this out, and we'll talk about why that was in just a moment. But this takes us to our first root cause. Why did the process hazard analysis not classify this release as serious enough? And it basically had to do with the guidance provided in the PHA process that is used at the refinery. So that would be our first root cause: inadequate process hazard analysis guidance. Why was the stripper slide valve in manual? There was multiple reasons. One was that the procedure was not followed, and the second had to do with the fatigue of the employee that we were talking about, because that person was part of the operational team when the release was occurring. Now, as far as why was the operator response not aggressive enough, we basically have to rule this out also as a root cause. And that's because the operator error and things like that cannot be considered root cause. We can't blame the operator. We have to ask, why was it that why did the operator not respond fast enough? And it's pretty simple that the operator wasn't supposed to be doing that. Now, we identified 6 additional root causes related to not following procedures, and we'll talk about that on the next slide. But the fatigue one had to do, there was a root cause related to gaps in the site fatigue management system. Okay, so what are those additional root causes? So first, specifically related to procedures, there was a practice in the refinery. There is a practice in the refinery of deviating from procedures without properly managing field changes. And this is something that's done pretty normally across the manufacturing industries. And there is I think the refinery does have a practice, but it wasn't rigorous enough. The procedures, also related to procedures, the operating procedure management system failed to ensure that cautionary statements were adequate. So procedures include cautionary statements, But in terms of a cautionary statement related to why the stripper slide valve needed to be in automatic, that wasn't present. Now, the topic of stop work authority, the refinery doesn't have a policy that allows workers to pause to reevaluate work when things go differently than expected. And so this valve was in manual. There was a number of other things that weren't going the way they expected. And it would have merited taking a time to sit back and think about what was going on and what would be the best course of action. We also identified a gap in training related to this procedure, and also a more general gap in training that didn't talk about the rationale for alarms that signaled the potential catalyst release. So we had the high alarm on the 4-stage separator. The significance of that wasn't included in the training. And one more thing in training, did not address instrument failure mode. So here, when we talk about failure modes, we're talking about the controller for the stripper slide valve and why the operator believed that it had to be run in manual. And really what we want them to do is, if there's a problem, call an instrument technician and get it fixed. Now, here's why we ruled out the malfunction of the stripper slide valve. And we know that the questions have been raised in the number of the public venues that we've participated in. It's possible that this question is coming. It was prompted by the explosion of ExxonMobil in Torrance, and this was caused by a degraded stripper slide valve, and that was the key factor in that incident. But this was a very, very different incident. And we were able to show that the performance of the valve, basically its ability to control the flow of catalyst, was not the cause of the high flow from the stripper to the regenerator. It had to do with the mode of control of the valve and the operator action when it was in manual. We did have data that showed that the stripper slide valve responded properly to the signals that it received, and there was also some modeling that was done by MRC that showed that if the stripper slide valve had been in automatic, it would have responded fast enough and accurately enough to prevent the incident. Now, there's a few more contributing factors that we'll talk about here. First, we'll talk about some distractions that occupied operators' attention. And this, I think, also speaks to our root cause related to, stopping to think what's going on. So there was that directive not to flare and not to draw additional propane. This basically sort of tied the hands of the personnel in terms of how they were trying to control the process. So that gave them that many more things to do, and that was a distraction. We also found some engineering design features that were not present in MRC's catalytic cracking unit, but they're common to other refineries' units. And if they had been present, they might have helped avoid the incident. And one is an advanced control of the differential pressure between the reactor and the regenerator. This was done pretty much manually by personnel in MRC, but it could be done and should be done in automatic. And also a direct measurement of feed flowing from the reactor. And this would also have helped having too large of an increment of feed that would cause the pressure surge at the beginning. So now let's talk through our recommendations. And so we'll take them one by one. The root cause of inadequate process hazard analysis, to clarify the corporate guidance regarding environmental catalyst releases. And we know that was also part of MRC's actions, and they have done so. We also recommended that they review relevant refinery process hazard analyses for similar scenarios. So other types of scenarios where they might have underestimated the consequences of or the severity of consequences of releases. And the second root cause had to do with the practice of deviating from procedures without managing field changes. And we basically asked that we recommended that the refinery review its procedures for managing field changes to ensure that that the changes of the type that were made here, basically putting the stripper slide valve in manual and keeping it there, are properly reviewed and approved. The effective personnel are trained on the procedure, how to use that, and that the refinery use metrics to track various deviations and make sure that deviations aren't occurring too frequently. Our third root cause had to do with operating procedure, the management system that failed to ensure cautionary statements. And so we recommended that in the procedure development system to add to the procedure development checklist to make sure that cautionary statements are included when appropriate. So that would be determining the situations in which cautionary statements should be used and then validating that they are being used. And more specifically, to update the procedure for that was being executed at the time to include a caution statement explaining the rationale for ensuring that the stripper slide valve should be in automatic before the feed is reintroduced. And we know that was also done by MRC. That's been completed. The root cause of practice of not pausing to reevaluate work when things go differently than planned. And we know that the refinery does have a stop work policy that meets the regulatory requirements in California. But we believe that it's important to update the other procedures, the pause work procedures or policies, to make sure that people understand when they're in complex situations in non-routine work that they should take the time to evaluate and what kind of things they need to do before proceeding. And add consideration of situational factors to the pre-startup safety review instructions. So here we are trying to start up that unit. So what are the things that we need to look at as the startup is proceeding? We had a gap in required training. And so we'd identified that the personnel running the shift that evening, we couldn't find records of them being trained in this particular procedure. And so it's important to make sure that the training, there's a very thorough training management system, but make sure that the appropriate training is done before a person can execute a procedure. And also we identified that the operator training did not address the rationale for alarms that signal the potential catalyst release. So again, to develop and update the criteria for operator training and review the training materials to ensure the basis for all alarms that are used as safeguards are included in the training materials. So that when for example, the operator sees the high level on the 4-stage separator, to know that means that a release could very well be going on. Operator training did not address instrument failure modes, troubleshooting, and when to call instrument technicians. So we wanted to standardize that. We recommended to standardize the approach for the response to malfunctioning instrumentation and equipment, and educate the affected personnel to deal with the failure modes, when to ask for an instrument technician. And there already is a program in the refinery for bypassing safety devices. But of course, the stripper slide valve was not considered a safety device, but it was a critical piece of control equipment. And so it's important to consider that. And then lastly, the gaps in fatigue management system. we recommended that the refinery modify their policy to include oversight of fatigue for all hourly and all salaried personnel that are performing safety sensitive activities. So if you're going to be performing that activity, your fatigue, it needs to be managed. There would be some people who had not been covered by that policy, will need to be educated in the change to the policy. And then, of course, the refinery leadership will need to provide oversight to that policy with relevant metrics that are collected. As far as the contributing causes, we talked about managing the differential pressure between the reactor and the regenerator. And we recommended that the refinery consider upgrading the control scheme for the differential pressure between reactor and regenerator to what's known as cascade control. We understand that the refinery is planning to do this at the next turnaround. We also had the lack of flow indication of feed into the reactor. That did make it a little bit more difficult to manage the reactor pressure surges as feed was reintroduced and manage the wet gas compressor to control that pressure. So we recommended adding a flow meter to measure directly the flow going into the reactor. That wraps up my part of the presentation. I think Nicole is going to talk about next steps.
Great, thank you, Scott. If you could advance to the next slide, please. So I know many of you are very familiar with the process here, but I would like to go over what our next steps are. So right now we are in our public meeting and 45-day public comment period for this draft incident investigation report. At the end of the 45-day comment period, Contra Costa Health will work with Scott Berger to respond to and address all of the comments that we have received here verbally tonight and also written. And then our final portion will be to do a public presentation of the final report to the Contra Costa Board of Supervisors through the ISO Industrial Safety Ordinance Community Warning System Ad Hoc Committee and City of Martinez. Next slide, please. So before I go on and finish the presentation, I wanted to take a minute to thank the members of the Oversight Committee and let everyone know who the team is that has been working on this for over a year. Our first Oversight Committee meeting was on February 16th of 2023. Since then, this Oversight Committee has been responsible for selecting the consultants who have been performing the evaluations to evaluate the incident that happened in November. They have spent countless hours reviewing reports, providing comments, and participating in meetings. And so from Contra Costa Health, I'd like to thank Michael Dossi, Sam Calvert, and David LeCount, our community members, Tony Semenza, Kent Hull, Ben Theriol, Pedro Babiak, Tom Lang, Deidre Castillo, and Cheryl Grover. From City of Benicia, we had Chief Josh Chadwick, City of Martinez, Steve Devine, and also Lauren Sugayan previously. And from PBF, Ken Axe and Nick Perkowski. So thank you very much for your hours of dedicated work through these efforts. And I look forward to continue working with you through our process of the safety culture assessment. Next slide, please, Scott. So now really what we're here for is to let you know that your comment counts. I have posted on here a QR code and also a website link in which you can access the incident investigation report. Just a reminder, this is a 45-day public comment period, so not only can you make comments here tonight, but if you have not already read the report and go through the report and have additional comments, you can submit those comments to us. And Scott, if you go to the next slide, I will be able to tell everybody how they can do that. So to submit your comments, you can email them to hasdap.arcteam@cchealth.org, or you can mail your comments to our office with the attention of Michael Dossi at 4585 Pacheco Boulevard, Suite 100, Martinez, California, 94553. Before we end and move into our public comment period, I do want to take a minute to talk about some additional context we have for anything that comes up related to hazardous materials issues. And so I'd like to turn it over now to Michael Kent, who is our current hazardous materials ombudsman. Here, I think we should be able to see you.
Sorry, I don't know if we got people over there and people over here. I'll stand here and see, hopefully everybody can see me. Anyhow, I'm Michael Kent. I'm the ombudsman for the county's hazardous materials program for the last 26 years, but I'm actually retiring in a couple of weeks. So I'm going to introduce the person who's going to be helping to take over my role. But the role of the ombudsman for the hazardous materials program was created in the mid-90s because a number of environmental groups had petitioned the Board of Supervisors to create an ombudsman position because they were not, frankly, happy with how the health department was communicating to them after a number of major chemical accidents. And so an ombudsman is somebody who answers questions and complaints about an agency, but does it in an independent manner. So I've served that role since its inception in 1998. Over the years, have been involved with a number of releases, or follow-up to releases, making sure that people are getting their questions answered. So in the case of this report, they're looking for comments, and I encourage you to make all your comments there. But the role for the ombudsman is, if you have questions about what's going on, to help you understand better what's in the root cause, or what was done at the facility, or what next steps are, and you're not getting those questions answered to your satisfaction, then please come to me for the next 2 weeks, and I can help make sure your questions are answered. And I've done that already several times for people related to this incident. But so please do make all your comments to Nicole as the way she laid out. But if you have questions that you're not getting answered, feel free to reach out to me. But I'd like to introduce Cameron Sue. So, excuse me. Why don't you come up, Cameron?
Oh, yeah. Good evening, everyone. My name is Cameron Sue, and I'm part of the Health Emergency Response Unit, and I will be taking over from Michael for the ombudsman role. And so how we're going to work it is that I will be kind of like the primary point of contact, but I also have 2 members supporting me when it comes to fulfilling the responsibilities of Michael. So in the ombudsman role. So I'll turn it back over to you.
And your email?
Oh, it's going to be the hazardous materials ombudsman email that's up there. So I will be the person behind that.
Well, thank you very much, Michael and Cameron. And Michael, thank you so much for all that you've done for us over the past 20+ years that you've been working with us. And, Cameron, thank you for stepping into the role. As we have stated, we do have a new email address here, hazmat.ombudsman@cchealth.org, which will allow you to reach out to our ombudsman and his team for support. So now we will be moving into our public comment period. As I mentioned at the beginning of this meeting, we will allow everybody 2 minutes to speak, and we are going to start with our Zoom participants. So if you would like to make a public comment, please raise your hand so that I can go ahead and start working on the process to promote you for comments, and then we will move to those participants who are in the room. So right now I only see one hand raised, and it's Alicia Goudet. And so Alicia.
Yeah, they did the whole testing.
You should be able to speak now.
Yes, thank you. Hi, my name is Alicia Goudet, and I'm with Healthy Martinez. Following the November 2022 spent catalyst incident, community members promptly called for a chemical safety board investigation due to concerns about the county's lack of technical expertise in analyzing complicated refinery systems. Regrettably, the CSB declined involvement, citing the circumstances of the accident. Assurances were given, though, that the Contra Costa Industrial Safety Ordinance represented the gold standard of safety and investigative standards, even serving as a model for CSB investigative methods. However, the report presented tonight confirms some of our fears regarding the county's inability to conduct a comprehensive technical investigation. Instead of focusing on the mechanical aspects of the incident, The report primarily highlights failures in both worker and management practices, which we are very thankful have been identified, but it relies solely on interviews and refinery record inspections without physical examination of the machinery that was involved. This stands in stark contrast to the detailed insights provided by the CSB's investigation update just 3 months after the November 2023 marathon explosion. Despite testimonies from workers indicating issues with slide valves in this report that describe them as sticky and bulky, there is a notable absence of investigation into the machinery itself. This lack of thorough examination is deeply disappointing, especially considering the inherent dangers for workers and our community associated with FCCU systems. As a community, we continue to await a more robust and appropriate investigation. Before I go, I want to sincerely thank Michael Kent for his service as the County Health Ombudsman. After the event of November 2022, I personally spent much time speaking with Mr. Kent, and he patiently answered my many, many questions and concerns. So again, thank you for your service.
Thank you. Okay, I'm going to ask if there is anybody else in the Zoom audience who would like to speak. If they would please raise their hand. Okay, I see Greg Karras has his hand raised. Greg, I'm going to allow you to speak now and start your 2 minutes.
Hi, Greg Karras, Community Energy Resource. Can everybody hear me?
Yeah.
I have more comments on the what I think are technical shortcomings of the independent root cause analysis than I could give you in 2 minutes. So I'm gonna reserve the right to respond in writing. I want to talk about one of the things that Alicia Gade very clearly pointed out that I think is really crucial and urgent right now because it could result in another incident and a potentially catastrophic one. And that is that because the county and and in particular this independent root cause analysis did not correct a key mistake that was clearly made by the company management, there's likely to be a serious and potentially catastrophic hazard that's still in place. And that's the slide valves, which at all other refineries where public information has been made available by the Chemical Safety Board and others, those slide valves wear out to the point where they're dangerously prone to malfunction, explosions within 3 to 5 years. There is no evidence that a slide valve can go longer than 5 years. This company, we now know, has never inspected or replaced its slide valves. They need to be inspected and replaced in most cases, 5 years maximum. Right now we're going on 6. We understand from the company's own statements that their current plan is to wait at least 7 years before even checking them. And we have written to the supervisors and the county today to ask urgently that in the turnaround that is now scheduled for next month, that you at least visually inspect them. It isn't enough to just guesstimate. That's what went wrong in Torrance when the explosion almost killed a lot of workers and cost the state an estimated $6.9 billion.
We're at time, Greg?
And it's what went wrong in Wisconsin. And I think that it would be a huge mistake, bordering on negligent for the company and the county not to take the opportunity to inspect now. You're taking a lot of the refinery down next month anyway. Don't put us at risk. That's not fair. And it's absurd to think that's good engineering practice.
Thank you, Greg. I'm going to stop you there. Our next speaker is Marilyn Bardet. So Marilyn, I'm going to allow you to speak and start your time. You may go now.
Thank you very much for this meeting. I'm definitely interested in what has happened at MRC from the early days in 2022, but also right to this moment. And I very much appreciate being able to participate and hearing from about the root cause analysis. But I want to echo Alicia's and also Greg Karras's comments, where even as a layperson, I know that technical issues are central to how you evaluate cascading events, and of which we have had in February involving an FCCU in Benicia at Valero. And so I'm particularly interested in how it is reported, not only about human error factors, which I always assume are part of management issues and sometimes inadvertent failures due to fatigue, all that. But the issue of technical problems that need to be parsed so that the community can understand why there are cascading events that lead to these releases that could lead to explosions must be understood. We cannot be patronized as though we cannot understand technical issues if explained properly and clearly. And I appreciate very much what I heard tonight about the shortcomings of the what happened that produced the releases of catalysts that everybody was noticing in that Thanksgiving event. So I'm extremely appreciative of this openness to inquiring further about this investigation and also its limitations. In other words, I'm really appreciative of Heidi Taylor's indication that what we really need to focus on too is community involvement at the root, at the beginning of inspections and root cause analysis to raise these kind of questions, because you cannot understand something if you don't have both technical and the human error factor in relation when you've got cascading and repeated events, one after another, that point to maintenance issues, etc. Thank you very much.
Thank you, Marilyn. Okay, and I see the last hand that we have up from our Zoom audience is Laura Hayter. So Laura, I'm going to give you permission to speak and you should be able to go now.
Hello, do you hear me? This is Laura Rosenberger Hyder. I think the workers should get more sick leave, like when they need it, even on short notice, like, because people often get food allergies, get really sick and can't function, and they're kind of dizzy, they're not attentive, and therefore, like, there's a lot of things that people get allergic to and suddenly get sick. There should be backup staff available, not short-staffed, and they should hire more people so someone could call in sick whenever they need to. All right, thanks.
Thank you. Okay, I'm going to do one last call for members of the Zoom audience before I move to the members in the room. I'm not seeing any additional hands, and so now I'd like to see if there's anybody who is present here who'd like to speak.
Where are we supposed to do that?
The camera is set here to our audience, so you should be able to speak and be heard from your position. Yeah. So Heidi, you may go first.
For the last 16 months, I've put my trust in this independent investigation. From the get-go, I was assured that the ISO has the power to develop and enforce corrective actions. I believed that the spent catalyst release was an aberration. I know better now. The report says when the night shift personnel started their shift, they found the stripper slide valve still in manual. And it reinforced to them a preconception that this valve was sticky and bulky. Among the personnel working that evening, there was a general belief that the stripper slide valve could be given a series of small manual input changes to valve position without a response, and then the valve would move suddenly, potentially more than desired. Your own report begs for an inspection of the stripper slide valve. When I asked when the slide valve would be inspected of Daniel Ingram at last week's Martinez City Council meeting, he said during next year's turnaround. It's been 6 years since that slide valve was inspected by Shell. There are two aspects to this investigation: what the people did or didn't do, and what the equipment did or didn't do. You have ignored the equipment. You are leaving us exposed, and that is unacceptable. We have waited too long for corrective action. I will not accept there's been a change in MRC safety culture. Since Thanksgiving of 2022, the abuses and the violations keep coming. More than 150 events. The only thing that has gotten better is MRC's public relations. I will say what I said at last week's city council meeting. You all are on notice. If that facility explodes, it will be because you didn't do the most obvious thing to prevent that kind of disaster.
10 seconds.
The investigation is not complete. Inspect the slide valve that MRC won't. If the ISO is the gold standard, then prove it.
Do we have other members in the room who'd like to speak? Jillian, your 2 minutes will start now.
Hi, my name is Jillian Elliott. I'm with Healthy Martinez. I'm not an expert. None of us in our group are experts. We're having to become more expert than we'd like to. We count on people at Hazmat and others to protect us. And it feels like there's a huge gap in this report. We're looking at a situation where we are blaming processes and employees, and I am deeply grateful that they are putting in training and better programs for their employees. But to not look at the slide valve, to not look at the compressor, to not look at the things that we know could cause issues, feels like if we looked at a Tesla accident with the automatic drivers, and we just blamed it on the driver and didn't look at the Tesla. So what I am really hoping is that we will make them do a real inspection of the facility, because we do know that no number of well-rested employees or processes can overcome the absolute dangers, inherently dangerous systems of a facility that's not in good order.
Thank you. Any other public comment? Linda? Your 2 minutes will start now.
Okay. Linda Olivera from Healthy Martinez as well. Just want to make 2 points. If money and cost is the reason why thorough inspections are not being made on this important equipment that could cause explosions in the end, I don't understand, with all the money that the big refinery makes, and I believe it's in the amount of $38 billion a year. If money and cost is preventing the inspection, this is outrageous, that they're going to take our community's lives, perhaps in the future, to pay for an explosion that may happen. So I'm here to support the idea of doing inspections now on the slide valves, not in a year. It's already been explained to you normally how often they get inspected, and we're way beyond that now. So, I mean, $38 billion profit a year shouldn't be keeping them from doing the inspections that are needed now. The other thing I want to say is that we're here speaking from the community as community members, but you know what? We're also concerned with the workers. If something big happens, people are going to get killed that are working there. So we're very concerned about them and their families. They're going to be left without breadwinners, without fathers, husbands, brothers. You know, we just want to make it clear that we, as a community organization, are very also concerned about the safety of the workers. Thank you.
Are there any other, Jan? Your 2 minutes will start now.
Quick. Jan Warren, Interfaith Climate Action Network with Contra Costa County. I'm here to thank the Health County Hazardous Materials staff, to thank the refinery workers who work to keep their fellow workers and the public safe, especially I want to thank worker A in this presentation. I want to say that I'm repeating what Supervisor Glover said, that the goal is to prevent something like this from ever happening again. I think we all know that if you've tried to get a stop sign or a red light someplace in your city, hard to do unless somebody gets hurt. And I think we'd be having a different conversation if some of these workers hadn't, we didn't like the catalyst release, but they kept the thing from blowing up, and they should be congratulated, and they should be given the rest, the support that they need. I've looked at this, I don't know how many times, and I'm seeing for the first time root gaps, causes, strictly in process safety management system, not the equipment or operator. I don't know how I missed that, but that's not my concept. And I don't think anybody who's operating equipment would go along with that. The management can't tend to alarms. There's too many gaps. There's too much turnover of staff and insufficient staff. And I'm holding the refinery corporation and those who are supposed to be doing the right thing by their workers in the community responsible. And so we're asking for the inspection of a slide valve. The frequency required to inspect is based not on a refinery's own policy, but reliant on best practices with the industry. Thank you.
Do we have any more comments from members of the room?
Kathy.
All right, I do see that we have one new hand that has been raised on Zoom, and that is Kathy. So Kathy, I'm going to go ahead and promote you now. You should be able to speak and start your 2 minutes. Go ahead.
Unmute. Thank you. I am actually asking, we're going to have the 2024 turnaround in May, and I'm asking that they deeply investigate the FCCU. I have tried to read through part of the document, and I want to bring up a couple of things. There are system failures that are small, but that have consequences. For example, on page 6, 2018, Shell Oil classified the scenario of a process upset severity as 2 on a 5-level scale. On page 7, 2022, PBF classified a similar potential process upset as a severity number 2 on a 5-level scale. The report that we have now states that the correct severity was 3 for both, and that correct severity numbers would have led to policies to prevent the release of Thanksgiving 2022. Another example of errors and flaws that were not also part of the investigation. For example, the instrument failure in the air blower set events in motion. That is a high opacity reading, an alarm, and exceedance of the refinery permit. This was not part of the investigation, but nevertheless, it's there, but it's just not going to be considered fully enough. But with the CCU shutdown, the wet gas spillback valve opened and was put into manual to avoid a surge.
10 seconds.
Cause and consequence. Then valves were opened to route propane to the wet gas compressor. This creates another problem that we get to later. This was all before the catalyst was released, as far as maybe give or take an hour or two. Back to the failure in the air blower, the CCU was shut down automatically with that failure that I talked about. And that involved the air preheater ignition. That's on page 8. It was repaired and the CCU startup started. Feed started on November 24th, day shift.
Kathy, I'm going to need to ask you to wrap your comments up, please. Time is up.
the propane valve that was left shut became an enormous issue later on, and that it required sort of a joggling back and forth using probably two staff to manually work the wet grass compression to close it and to manually cut back on the propane so they wouldn't run out of propane.
Kathy, I'm sorry, I'm going to have to stop your comments now.
That's fine. I think I've said my piece.
Thank you. Okay, I do not see any additional commenters, and so now I'm going to turn it back over to Supervisor Glover for closing remarks.
I want to appreciate all of the comments this evening. And I want to thank the committee members and community members who's participated in this process through the Oversight Committee, the ISO meetings, the Community Warning System meetings, and a special thanks to the Oversight Committee for the countless hours that you've worked on this project. We've all worked together to make MRC accountable to improve the safety processes. There's still a lot of work yet to do. We are currently in the process of completing the safety culture assessment of MRC, which should be done shortly. As always, we want to continue to welcome the feedback and collaboration that we receive from our community and the Oversight Committee. So thank you all for your participation. And I also want to just congratulate Michael Kent for the many years of service. And we look forward to, well, we're hopeful that you will enjoy your retirement, and we welcome on your predecessor. Thank you.
Thank you, Supervisor Glover. And with that, we will conclude our meeting today. I will ask Scott if you can put the slide back up that shows how you can submit your comments. Thank you, everyone who showed up both in person and on Zoom. And we will continue to report out on both this report and all the rest of the Oversight Committee work. Thank you and good evening.